Good morning. It is 7:30. It's Sunday. And we got work to do. So where did we leave off last time? I think last time what we had was we started messing around with a whole lot of everything. So the next thing we have to do is we have to figure out how we're actually going to do the water, I think. So let me see, we got some tasks here. Why don't we segment them? So one of the things we could do is move the waterfall blueprints into the gameplay folder, get those organized. And then we should actually start working on water. So I'm just going to start off with moving stuff around because it's kind of brain dead, but also very important to do. So we got our test content for our water. So what we're going to do is, let's see, objects, cave, let's just make a new folder for objects, water. And then we will throw stuff in there. So we need a water noise texture, waterfall, waterfall normals, waterfall texture. Let's see, we don't want this waterfall mask material. Is this used by anything? Is this actually used by something? I don't think so. I think this was just like some crap that we actually should get rid of. So let's see, replace references with test shadow. Let's see where this thing actually gets referenced. It's the test waterfall masked. No results found. There it is. Alright, replace references. We'll have to check out all the files. Alright, now we should be able to... Alright, that's deleted. So you got the waterfall, the mesh, all this stuff. We'll move all of this over into this objects water folder. So I'm just kind of waking up still. I mean, I've been awake for maybe an hour or whatever. So just gonna be slow, steady, and just work on stuff. All right. So this is going to be waterfall material. This will be simple waterfall mesh. Alright, this will be waterfall shadow material. Let's call this water Perlin noise text. I'll call this the waterfall surface text. And one thing I'm curious about is how big is this level currently? So this is the waterfall at night. It's currently what, 96 megabytes? Oh, that's built data. So it's currently only 1 meg. But then we have 100 megs of built data. I'm guessing that's lighting stuff. Regardless, it's not too bad. Alright, so if we're gonna do some water, how come I can't see this object? This light mass importance volume. I have absolutely no idea why. I can't see it. That must mean it's not important, right? Just because I don't understand it means it's not important. So we've got our sky sphere. Alright, so our test water. So what are some things that we're going to need for our water? Well, we need to figure out a lot of things. We gotta figure out what we even need. And I mean, nobody's ever done any water shading in games before. You know, people don't do that, right? So let me just look it up real quick. If there's any resources just off the bat for water. So I was trying to figure out how to texture and animate water. For animation, I read somewhere you could do with morph targets, materials. Look at this guy's ridiculous everything. Looks about right. And that's kind of what his water looks like there. Which we don't really need that sort of stuff. We need more like cartoony water, don't we? Let's take a look at his material that he had real quick. Of course, we can't see much of anything about it. What could possibly go wrong? Downloading some code from the internet and running it on your computer. What could possibly go wrong? So let's just slap it in there, and we'll take a look at what this guy did, just to kind of give an idea of what we could start with. So we're going to try to import these assets. It's going to add these files to source control. I mean, I don't really want to do that. God damn it. I really don't like the source control integration with Perforce with Unreal. It's just trash. So he's got all these textures for all this stuff. These are all textures. There's absolutely nothing in here that's not a frickin' texture. Alright, well that's just complete trash. Well, there is a material in there. Well, where is it then? Alright, that's where it was. Alright, so this guy set it up as a translucent object with subsurface shading. I mean, a translucent object's not going to work with shadowing and stuff like that, so that's pretty much useless. Uses distortion. Hello, Kento456. Good morning. Right now I'm going to be starting off working on some water stuff. Oh, Ashrafs though. Hopefully you guys are doing well. I am just getting started with water stuff. So I just snagged somebody's water material they had posted on the forum just to kind of get an idea about how other people are thinking about water. And it looks like they have panning textures, and they have panning textures for waves. Where do all these things go? Like, we've got distortion that goes and plugs into refraction. So they use refraction, they used world position offset for vertex shading. Will today be another frustrating day? I hope so. Jesus Christ, yesterday was rough. But, I mean, we figured it out, right? I mean, vector projections, how do they work? And just, you know, looking up online for, like, help on vector math and then finding the wrong damn formula for a scalar projection. And I was thinking about it while I was asleep last night, and I actually almost already had the right scalar projection vector the day before. On my like half-hearted stab at like getting it right, I just wasn't dividing by the vector after I was adding up all the components, because that's what the damn dot product was doing. Is we multiplied it together and then we added all the components up. If I just fucking divided by the vector after that, that we were projecting onto, I would have been finished. So literally, like, if I had been on point, I would have been done with that in 5 minutes. But instead, it took like 4 hours or more because, yeah. Because I thought I was dumber than I was, which is, I guess, true. Alright, so what are people using here? So techniques used for other water. They're using refraction for distorting things under it. They're using subsurface lighting for, I guess, just lights coming through. They're using translucent stuff. Is it forward shading? What kind of shading model were people looking at here? Looks like they have no tessellation. I think they are using tessellation. Surface translucency volume. Line be calculated. Alright, so using the surface translucency. Subsurface lighting, blending mode, material mode is surface. Alright. Alright, so let's see. The distortion stuff was this mass multiply on a depth fade, which is a material expression this guy put together. I mean, that distortion was going to both refraction and world displacement. So they're using vertex driven displacement. So the question here is, are these verts on the model or are they auto tessellated? And I'll have to read about the tessellation stuff that they got available to see if basically we can take, you know, a flat plane, and then we can, because really what you'd want is you want the water surface to be fully simulated if you wanted actual waves and crazy stuff. And that means either you have a bunch of vertices so that you can actually move stuff around, or you've got, you know, some sort of what appears to be, you know, some like occlusion, parallax occlusion sorts of where you're looking at something, but even though you see it, it like can draw into itself, so it can kind of provide the illusion of depth while it's not actually doesn't actually have any depth. Vertex stuff actually does have depth because it's actual geometry. Just a bunch of panning stuff. Fake reflection specular. Reflection vector. The reflection vector expresses a similar spirit to the camera vector, but it outputs 3-channel vector representing the camera direction reflected across the surface normal. Reflection vector is commonly used in environment maps where the X and Y component of the reflection vector is used as UVs into a cube map texture. So we could like look into a cube map and grab the sky based on a reflection, so we would be able to see like if there was a mountain in our cube map. Well, we don't, that's not going to be very helpful for us. We want real planar reflections. Though I guess planar reflections aren't going to really work too well if we aren't a plane, right? Like a planar reflection, it's got plane built right into the name. So things to think about. Planar reflections won't work for choppy water past a certain point. Because basically for our planar reflections, if this is our water surface and our planar reflection volume looks like this, if our water surface is instead kind of choppy, you know, like that or something, it's going to go outside of the planar reflection volume, and or it'll look weird and won't have anything looking good on it. Alright, he does ripples, and how does he do ripples? He looks into a texture, he's got a whole bunch of math for stuff based on time, so he's got a texture sample, X and Y values, and those get fed into rain, which get fed into reflection and diffuse, and eventually go into the emissive color. Alright, so ripples are something drawn onto the surface. And then we've got a whole bunch of stuff here for world position offset. This looks like a wave to me. There's like a whole bunch of sines and cosines and all that sort of stuff to get nice curves, right? So that's going to be making a wave and then adding it into some other crap with ripples in order to have a world position offset and a world displacement. Alright. I'm going to delete this folder. and we'll never look at it again. I like how we can't actually delete the damn folder. That's really funny, actually, that Unreal doesn't actually recursively delete folders properly. Alright, so I'm going to keep looking up some water stuff with Unreal 4 and see what people are looking at. So I've got this like water shading tutorial. What are they basically saying? Like normals are important for what defines wave speed. That just looks like shit. So it looks like pretty much people are just doing all sorts of crazy stuff. And they're using tessellation. Surface translucency volume, yeah. Responsive anti-aliasing, is that what that is? Alright, so this indicates material should be rendered using responsive anti-aliasing. Improved sharpness of small moving particles, such as sparks. Only used for small moving features because it will cause quite a bit of aliasing in the background. This guy just uses some colors, a Fresnel effect, opacity. Blame Windows somehow? Stupid Windows. I always blame the engineers, because I've, server engineered, worked on Windows machines, worked on Linux machines, worked on all of them. You can complain all you want and be like, well, how come I can't just delete a folder? Be like, just write the program, just stop being lazy, write the program that scans the file system properly and actually deletes stuff. Like, it's really not, like, once you get over yourself, it's a lot easier to actually write code. It's like, but I shouldn't have to. It'd be like, it doesn't matter. I don't care. I don't care that you shouldn't have to go through and scan the file structure and do all the crazy stuff. I know, it's hard. Because we had to get all of our code working for like file access and all sorts of other stuff at Amazon when we had Cylance running there, which is an antivirus thing, which would just randomly lock up files on your system. So you'd be trying to like, I wrote a patcher for one of the Amazon games that needs to like download your game executable and then run it, which is exactly what a Trojan horse virus does. So I'm basically writing the equivalent to the antivirus's point of view, a Trojan horse program, but it's it's to run our freaking game. So this thing would try to like download the files and write them to disk, and like things wouldn't work because the folder that the operating system said was created hasn't been created yet because Cylance overrode the DLLs for Windows and is checking to make sure you're not some nefarious thing. And of course, we're using unsigned builds because they're just hot off the build machine or whatever, right? So it's not like you can wait around signing every damn DLL. So the antivirus is like, holy shit, where's this program that was made by you know, this nefarious studio, Amazon Games. So you had to deal with that and like actually have it wait and be like, well, I can't write the disc yet, I'm gonna keep trying. I can't rely on the operating system calls actually having succeeded, even though they said they succeeded. And you just gotta learn how to program for that. Alright, let's look up tessellation. Still, I don't know anything about how Unreal does tessellation. Tessellation is a DX11 feature and requires hardware that supports DX11. What it does is it splits triangles into smaller triangles at runtime to increase the surface detail in the mesh. The effect can be very slow to render and should be used within reason. I guess you have to have DX11 in order to use it. Let's... So my question is, if we actually use tessellation in any of this stuff, does that mean we're DX11 exclusive? Which would mean if we ever wanted to ship on any other platform, we'd be totally screwed. Good life lessons, if a bit salty? Yes, the best lessons in life are salty. That could be posted and mean a lot of different things. Alright, yeah, here we go. Multi-platform tessellation. Will tessellation in UE4 work on platforms where there's some restrictions? DirectX 11, OpenGL 4.0, and OpenGL ES3. So there should be no problem with Xbone and PS4. You should not consider any issues. You should not encounter any issues when using tessellation with project compatible under the given restrictions. So yes, Xbox One, PS4 should work. At the moment, 15th of July 2016, tessellation on PS4 doesn't work. Yeah, see this. These features are limited to use DirectX 11. Enabled as such, they should be secondary polish effects unless you're targeting DirectX hardware exclusive. Alright. So we can't use tessellation. We cannot use tessellation. That's what I wanted to find out. If you know, we could actually use it or not, which, I mean, that's just how it is, right? That's why when you look all this stuff up, you need to start figuring out, like, okay, what are people using in order to make these really cool looking effects, and then if it's like, oh well, we use tessellation, it'd be like, you know, sorry, but we live in the real world, where we can't use all of the toys. You know, it's a nice science project or something. But we need to figure out how the hell to do this crap. Alright, so these guys are using ripple effects with Fresnels combined with the base color along with refraction. And these guys are using particle systems. Yeah, whenever there's a particle system, like I only want to use particle systems as kind of a last resort, because particles are nice and everything, but they're kind of like, at some point it's like I just need to obscure what I don't have working properly. You know, like if you could do it with geometry, if you could do it with just, you know, your material, you would. So whenever you see a particle system, it's like if it's not because of an explosion or something else, it's kind of like, well, we're just going to cover that area up. Just put a whole bunch of shit in the way, and it'll look fine, you know, no problem. And these are under particle effects, so yeah, I guess that makes sense. Let's see what other people do for like swimmable water. Using a physics volume in conjunction with a post-process volume to get a basic look and feel of swimming underwater. Well, post-processing effects are different. And like I get it, yeah, throw a film grain effect on there with, you know, a lens flare coming off. Well, that's kind of the thing, Kento 456, is it's whenever you have particle systems, you know, usually it's the more the merrier, and kind of what ends up happening is you have to trade development time. Like, I can make a particle effect that looks pretty good if I use a bajillion particles, and it's not going to take too long. But if it's like, okay, use only a few particles and still make it look good, you're like, ah, well, now I've got to do some real chin scratching. So let's see, physical water surface. Alright, physical water surface, easy to use and physically correct water shader with great runtime. Those are all styrofoam blocks. Alright, so Gerstner waves implemented using physically correct waves factor. Yeah, adaptive seawater, water motion, high quality buoyancy. A player controlled boat is included. Buoyancy is implemented in a blueprint component. Alright, so they added a whole bunch of crap to make a sea. It's like a whole bunch of stuff all laid over each other. Calculate the wave height. Let's take a look at this. What do we see when we look at this? I see a lot of vertices moving. Like, even when you look past it, like you can see there's a grid going on, and we're using world space displacement. So this basically is a huge plane with lots and lots of vertices moving around, and you know, squishing and stretching and doing all that sort of stuff. You can kind of see it. And actually, it looks awful in the distance. Like, look at all that anti-aliasing garbage. It just looks, it doesn't blur together nicely. It just looks like a fucking mess of pixels. And you can see with the wireframe that yes, it is just a gigantic bunch of verts moving around. Yeah, and he's got the anti-aliasing stuff needs to be turned on. The water equations are implemented on the assumption that one of your is 1 centimeter. If the objects in the game have different sails, they will not be correct. Floating objects are not lit. Since floating objects are moving, they can only be lit using dynamic lighting. Make sure you avoid masses large enough. I see flickering artifacts. Alright, so it seems like people have made a whole bunch of stuff. With, yeah, it's a lot of vertex shading, moving stuff around. So the question would be, the questions to ask would be, do we move vertices, like, are there actual waves? And as in, do the waves actually come off the surface? Or they're just like maybe ripples that look like they're there, but we're not actually moving verts around, or just we're just drawing it on. Let's see. And then how would we actually draw on waves? Like, you know, and how would we interact with it? Because some of the things that we'd want is like inside here, you know, we're going to want ripples coming off of this waterfall right here in specific ways. And, you know, of course we're going to throw some particles to obscure, you know, that. But if we had ripples, how would they work here? You know, like, we'd need lots of motion coming out here. Like, we could... How would we model everything, right? Like, would we use some sort of interactive flow field sort of thing? Where we'd keep track of some sort of... You know, we could render to some sort of texture or something and move water, you know, around. But, you know, this is a big flat thing, right? Like, we don't know where the hell the shore is. So, how would we model the shore? Yeah, how do we know where the shore is? Like, if we rendered this thing, you know, if we took a picture from above or something like that and saw what we can actually see, we might be able to get a texture, kind of like, you know, a mini map or whatever, you know, get a orthographic texture, draw only the objects that are around us or something. We'd be able to maybe get a good looking shore, you know, basically draw everything, you know, draw black and white. So like white would be blah and black would be the shore. That might be one way. We could do physics tests or something else. I'm not really sure exactly what we'd do. But there's a reason like all these tutorials and stuff like that have water in a square pond. Like, you know, otherwise you'd have waves that are going into, you know, it's real easy to program a square. Or a whole ocean, which is just a gigantic thing, right? And that's why a lot of games will use a height map for their terrain. So you basically just pass the height map of the entire world into your water shader for your ocean, for your island game or something like that. And then you know where the shore is because you're like, oh, where's the height map approach 0? Okay, cool. Well, when this is between certain values, then we just switch to our shore shader and stuff like that. Well, I mean, not your shore shader. Your material will do things like, because it knows where everything is based on the height map. You know, which would be interesting here because if we needed to draw if we needed to know where shore was, we'd basically want to take all these rocks and stuff like that, but we need to know where the height of the rock actually meets the water surface. Because, you know, this rock might be above the water, but it's not intersecting. So, like, we have water here, we don't have, like, you know, it's more complicated than that, though, isn't it? Like, shore is going to be where things are close. We'd actually need, like, you know, ground under the water in order to actually create a shore effect. And then we might have problems with cliffs. Because if you had a cliff coming out of the water, how do you know, like, how do you transition to shore just like that? You know, there would be, like, no transition. Oh, that's interesting. Look, you can, if you move just a little bit to the left here, these shadows don't appear to work anymore. Gotta love lighting. How do we have water flow? So if we look at our concept art shot, we've got these ripples coming off, and I would imagine those ripples would be moving outwards. And we also, don't we have some more concept shots that have water in it? And we've also got this, and we'd want, ripples that come along the bank and stuff like that. And we have actual waves here. And we've got these water, where you'd assume something fell in, we'd have splashing. So how do we make splashes in water? We're going to need splashes. Who made the concept art? Well, that would be Adam Phillips. If you're unfamiliar with Adam Phillips, he made the Bitey of Brackenwood series. In fact, some of the other people that are on stream, like Hurricane and those, they actually saw him draw all these on stream months ago. So he put like all these pictures together when we were starting back at January, putting them together for what we want the game to look like. Yeah, he's a pretty good artist. You might say he has a few skills. He teaches courses and stuff like that online on how to do effects. Yeah, he's the assistant director on Bob's Burgers as well. So he's got a bunch of Bob's Burgers work he does during the week, and then he's working on the game on the weekends. Alright, so make splashes in the water. What else are we looking at here? So what kind of strategy should we come up with for dealing with this? So if we've got ripples coming out of a thing, right? Like our basic strategy could be that, let's see, strategies for solving these problems. We could make a texture that we update every frame, which holds wave data. What? He's not allowed you to see the stream? It's only for subs? What are you talking about? He's doing a sub-only stream? Or he did one? Or when he was drawing these concept art pieces, he locked it down so it's sub-only. So if we made a texture every frame, that holds this wave data, we'd be writing to this texture, and we'd be able to. So what this would kind of look like is you've got this grid, right? And when a splash happens or something like that, right? What we would do is we would draw, onto this grid, onto this texture. We'd actually draw the values, and we basically have this. And what we would do is we would have like an array of waves, or an array of wave effects, and we would then we would update all of them. So we'd have like this circle that had like a radius and an amplitude, and we would render this thing every single frame, drawing onto it, and then we could pass this texture into our material, and as a result of that, we could just reference this thing and be like, oh, there's, a wave here. The wave height at this point is 0.2, meters or something. So I should do something about that. And that would be in pixels, so the resolution of that could be very high or not. And we could have some smoothings, like some lerp effects and everything else. And we could have perfect modeling of those waves and splashes and all sorts of stuff. And you could add effects to the water. So if you had like a waterfall or something, you would basically have like a wave emitter, and you'd put it here, and like every so often it would make waves that would spawn from its location that would kind of come out. This is traveling in this direction. And this would be like, a rock falls in or something. And if these were all modeled so that, they would get less big over time or whatever, we could do that. And then we might be able to do different shapes, right? Like instead of doing a circle perfectly, you could do an oval, which would come out like that. And we could give like a speed or something like that, maybe. Like if the waves were at different speeds. Well, that would be interesting. Basically, we could have like if we had a flow field or something like that, right? Where what? All right, Kento, 456. Go get some sleep and have a good one. Yeah, I'll link you his channel real quick. He has not been. Yeah, that is Adam's channel, and if you're interested in the game or the development blog, we got those as well. So the question is, if we had a direction, like, you know, if this was a river and water is going this way, when we'd have like, you know, a splash would happen, but as this splash came out, right, it would actually travel like this, right? You know, because like the speed of the wave would actually move outward. So how would we actually do that? Because if we have like the complex scene that we have right now, you know, let me just draw that out. I'm going to use some pretty awesome iconography here. So we've got a waterfall right there, and we've got, like, you know, the surface looks something like this. You know, we've got rocks that are filled in, and, you know, the shore looks something like this. You know, what's kind of supposed to happen. So if we make a flow field sort of thing, let's see, do we actually have like an arrow shape here I can use? Yeah, okay. It's like that.